Okay, yeah, we're starting now, actually. Yeah, just gonna write some code this chilled Sunday afternoon on the side. All right, just turn down the music a bit. Okay, I think, yep. So we left off, I think it was on Friday evening. Yeah, again, it's Rust programming. We're going through the Rust book and Rustlings. That's like some set of exercises in Rust. Yeah, and let's. I think we left off somewhere earlier. It's we're looking at result. I think it was. Yeah, and I think I think we also we finished with the question mark operator. Yeah, and yeah, multiple error types. I think we did this as well. Mm, yeah. And oh, this even has other sections. This uh, did we do this? Okay, I don't think we did. Oh, we did. Yeah, we did this one. Yeah, double first. I think this was the one that we did last. Yeah. Yep. So left off. Find error types. Yeah. I think this would be yeah. Okay, there. I'm just moving things around a bit. Yeah. This is where we run the code. I think. Yep. So we have yeah. It's okay like this. So there's something I wanted to try. Um, so we wrote this program that's just this a function called double first. It takes a vector that has string slices as types, string slices, yeah, and it returns a result of I32 or custom error. Custom error is a unit struct that we define here, and we implement display for it. Yeah, and double first just tries to get the first element of this vector. If if there's nothing there, we provide a custom error. Yeah. Otherwise, we act um on the result on whatever is returned from first. Yeah, and that's what we do here, where we parse it. That's like converting it to an I32. If we fail to do that, we map the error to a custom error. Otherwise, we just double it. That's what we do. So what I wanted to see here is what if this was an empty array, and I wanted to see what yeah, that's just what I wanted to see. Sorry. So it just says invalid first item to double. That's all. When it's empty array, because when it calls first, yeah, exactly. When it calls first, it's going to So okay, or it's like, is there value, or otherwise this is how you construct an error. So it's going to construct this error here. Hmm. Actually, I'm thinking about having two types of errors. Hmm. So this and the other one. But anyway, I think we get to that part afterwards. Yeah, right now let's continue what we have here. So next, to go to the next thing, boxing errors. I think we did this. No, we didn't do this, but yeah, let's just look at the code. I think it's literally the same. So they create a result type that is, yeah, we create a result type here, and we use that result type here, and also here. Fine, but then what's special? What's different between this and the other one we had before? I think the difference is that here we're using okay or else. Yeah, because, and for map error, we're using from. Oh, that's not the only difference actually. Okay, now I see a couple of things. One of them, I see that we're implementing error for empty vec here. Yeah, and okay, I think this is an example that we should play around with. So a couple of things are going on. One, we create a type, a result type that takes a value, which is t, a generic value, and the error is a box type. Yeah. So which means whatever is an error can be returned from yeah, from double first in this case. Yeah. Because yeah. So whatever is an error, and that's why we implement error for empty vec. But then we didn't I mean, let's see. I guess it's going to use the default error implementation. Let's check for the error trait. Yeah, this is the error trait here. So these are the provided methods in the trait. Here's an example. Wait, so first of all, you have source function, description, cause, provide, yeah. Errors must describe themselves through the display and debug trait. So implementing error trait only requires that debug and display are implemented too. Okay. Debug and display. So you just need to implement display for your struct or your type here. So here we have a read config error. Yeah, this is our error. and we implement display for it, just specifying how it should be displayed because it doesn't know how to do that. And then we can implement error for it. Okay, and then debug is also here using the default one. Okay. This is what super error struct, implementing display for it, and then we implementing error, and basically is overriding the source or specifying the source. Okay, well, that's okay. At least we know what to do about error. So if we go back to, where are you? Yeah, here. Yeah. So we are implementing error for empty vec here. So we try to do it first on the vector, and then we do OK or else, and we're using into to try to automatically convert this to box. Convert to box using into trait. All right. So we're converting an empty vec into an error with empty vec into, because empty vec implements error, so it knows how to do that. Okay. And then for map error here, we're using from. So it's also going to convert, so it's convert the error, which in this case is a parsing error, to a parsing error to an error. Does it know how to do that? Converts to box using from pointer. How does it know how to do that? But how does it know how to convert from a parsing error to an error? So we need to find that, or check rather how that's done. So let's see the parsing error. So display is implemented. Yeah. So actually, error. So we have an implementation. So we implement error for parsing error. I mean, this is already provided in the standard library. So if we go to source, for example, we see that, well, display is implemented here, but here, yeah, we see that error is implemented for parsing error, and and that means that if we specify from, if we use the from trait, it knows how to go to error from parsing error. Okay, so that's what's going on there. Okay, I think that is That's the only thing that's different in this implementation. Nothing else. Okay. I mean, we just tried to write that version. Let's do it actually. Yeah, let's actually want to write it as well as this, even though I could reuse a couple of things, but whatever. We need to write some piece of it. All right, so we want to say double first, and again it takes a vector that is a vector that contains a string slice, and it's going to return us a then let's create our type. We're gonna call it, I somehow like to distinguish this. I'll call it double first result. Excuse me. Double first result. Yeah. We declare the type. So we're going to use a generic type. And then yeah, so double first, it's going to be a result. Actually, that will be from std result of that, and std error. Yep. Actually, not exactly like that, but this should be. Oh, why does it say din already? But it doesn't have the box. Okay. So double first result. That's it. Maybe we'll make things easier for ourselves by doing okay. So here we can say same thing we can do here. Okay, and so this is going to be a double first result of I32. Yep. And yep. So now I'm gonna take the vector and try to get the first value. Yeah. So when we try to get the first value, this is the first value here is a result. I think it is. Oh, sorry, it's an option. Yeah, and then exactly makes sense to be an option. So first is an option, which has like some or none. Then we're gonna try to process is by, process the option, or maybe like first even convert the option to a result, because that's what we return. So we use OK. OK will give us the um value, but we need OK, maybe like or. We can do OK or and provide our struct, which is our error. Let's call it double error. It's a unit struct, so we can add an attribute debug for this, and we can, that's a struct anyway, double error. So yeah, we can say OK or, and we can specify how the error can be constructed here by saying double error. We can do that. Yeah, it's just complaining about stuff because we haven't finished doing that. So you see, this is result that has string slice, or rather reference to string slice, and double error. So but then we're gonna have a problem because double error is actually not an error, because we have a box error here, so we would need to implement error for that. And when we implement error, because the error has been rendered to the user, browser doesn't know how it should do that. That would make sense. So we have to implement display, like how the struct should be displayed. So first I'm going to implement the error, and I want to tell me that it doesn't know how to display this. Then I implement display. So let's implement error, or better still, better yet, error for double error. Yep. Actually, yep. So so I was saying, now it says that it doesn't implement the display trait. So prefer it like this. So now let's implement display. I think it's fmt display for, and we're going to use the fmt, sorry, okay. Okay, so what's the problem? I see how it where's the issue? Mutable reference to that. You use the formatter. Expected struct. Don't tell me it's because of clone. Is that the reason? That's not the reason. Oh wait. Sorry, this is wrong syntax. It's F that is as a mutable reference to that. Yep. So you want to display the error? Yeah, okay. We can just say as simple as that. Now our error trait works. Okay, now that we have that, so here, yeah, so we are going from, so we do first to get the first element in the vector. We do okay, or we can provide the error here, which is a double error. Yeah, this can actually, but wait. So it says expected result I32 boxed this, but got what? So it's expecting, yeah, expecting this found unit type. Yeah, that's fine. That's because we haven't finished writing this. So, but again, here we can actually use like or else, yeah, the empty argument here to the function, and specify that it is gonna have to go from a, or like how we should generate an error when we give it a double error. Yeah. So I think what we saw earlier was that we can use I think, yeah, I saw something that looks like we can do double error into, but it's not a double. Yeah, okay, yeah, that's fine. We just need to create a double error. That's what we need. It knows how to automatically convert that. What's wrong with my keyboard? I need to restart this thing. Okay. So we need to specify convert this type into the inferred. Okay. I mean, that's the same thing as using okay or double error. I think, I mean, I can see that already. So now we have a result. Why is it saying unknown? We're not done. Yep. So again, what we have is a result. If there is, yeah, we need to process this and say, so we take what we get from here. That's in this case now the okay. So assuming we got something, which would be the string, yeah. So I'll say first value string. That's what I would say. We're taking that now, and we can do something with it. So when we have, wait, by the way, is that actually the, is actually the first value string? No, it's not. I think what we have here is a result. We have a result. So we're taking the result. So I'm gonna, it's not, why does it say it's a first value string? Actually, I think it is, right? Yep. It is first value string, that's what it is, because we even see that here. So the first value string, we take that and we try to parse that. So let's do, let's try to parse that to an i32 value. This will give us, this is a result. That is a result, and we can try to map the error quickly. So we can do a map error. So if it's an error, we want to go from, if it's an error, we want to quickly go to our type of error, which is a double error. But again, remember that what it's going to return as error here would be a parsing error. And we already know how to go to an error for a parsing error. So we want to take that error, that's a parsing error, and instead of giving a parsing error, let's go for a double error. Wait, hold on. I saw some syntax like it expects an argument. What if I was doing remember that we actually got an error from here, which is a custom passing error. So why don't I say error, which is the passing error, and then say converts this type from the input type. So converts to this type from the input type. Interesting. When you say from, All right. So it knows to go to an error, or like in this case, yep, an error from the passing error. That's what's going on. Yep. I think that will be it. Yep. That's it. And that's the error is the error that the target error, which is on the return type here. Now we have been able to parse the or at least map the error. We need to now process the correct case. So now map. We need to take care of the wait. That is a result, yeah. So we need to take care of the regular case. So this will map a result TE to result UE. Yeah, so we would map the value, which is now a number, because that's been converted to an I32. So it would be val, which is an I32. We just say double it now. And that is it, actually. But if I did this and I did this, okay, then right. So why is it complaining about from error? I think it says there's a better way we can do this. Let's see. It says redundant redundant closure on by default. So are you saying that there's a redundant closure? What? So I just need to do from. Let's check. That thing was redundant closure. Help music is not too loud, by the way. So it checks for closures that just call another function, or where the function can be called directly. So I'm just gonna stand a bit. Okay, so it's bad because needlessly creating a closure adds code for no benefit. An example is you're trying to do, okay, this is just going to call another function like this. It says instead of creating a closure for this, foo is a plain function that takes exactly one argument. All right, let's just do foo. It knows to do that. I see. So we can just go back to our code because it's from and it's exactly one argument, we can remove it. And it knows how to do that. Okay, that makes sense. Right. So we're able to use this to do this. I think I prefer a situation where we move that down a bit. And now we now we can try to write this usage of the double first. Yeah. So let numbers be a vector that has like 3, 4, let empty be a vector, yeah, that has, yeah, it's empty vector. Let strings be a vector that has tofu eba. Yeah, I think it's okay. So we can call double first for each of them and say double first numbers is this or that. Let's do print line, or maybe, yeah, because actually we are getting the error. Let's not forget. So we're getting result which has a value if he succeeded or an error if he fails. So what's with empty here? Type annotations needed for a vector that is empty. I mean, do I need this to be a vector? I don't think so, right? Why don't I just simply say what's wrong? You still need type annotations. How do we say empty, by the way? Where is it? Come on, that's exactly what I did. So what's the problem there? This is what we have. So what are you complaining about? Oh, I'm gonna leave it like that. Let's see. Maybe by the time I try to use it, figure it out. Yeah, so I was saying that because we're receiving 2 of them, we should write a print function that's gonna take a result. So it should take a double first result. Yep. And do not return nothing. Yep. Now it should print. It should print result for us and say I want to print the input as well. So I want to print the input. Why don't we say, wait, again, we don't have the input, sorry. We're passing the result here. So we have to print it before we get here, okay? That's fine. And now let's print the double result here. Okay. We can print, we can get the okay. We can unwrap it. Oh no. Remember we don't know yet whether it succeeds or fails, right? We don't know that yet. So if we print this on the tofu one, the strings where we have tofu, it will fail. So let's match on the result, and where it's an okay of an actual value, then we want to print yeah. I think it was, I'll pretty print this thing. Is it like that? I see. Result. Then we do the error variant. Remember the error is an error which is boxed in, whatever it is. But actually, we can actually use a pattern matcher it, but we know it's going to be a double error. Yeah. So we can print this and say the error is a is an error. And I think that's it. This matches a statement, so this works. Yeah, so if we do this, we can print. And now we can say, let's print. So we do this for numbers first. Yeah, we can we print at the same time we do this? Yeah, we can. Actually it's double first. Numbers. So the result we returned there. We do the same thing. Empty. So I want to see what happens. Oh yeah, so now the error goes away. The error about type annotations needed went away now. Well, if we wanted to take care of it, let's see. Yeah, we just need to specify the annotation for it here by saying this is a vector of I32, and then that'll go away. Okay, that was okay. That's okay. Oh wait. Yeah. I'm not I32, sorry. It's supposed to be, yeah. So the last one is strings, and that's okay. So now we can run this. Besides, I don't need this anymore. All right. Yep. So let's run this and see. Run the main function here. So yeah, so for numbers, we doubled the first, we got 6. Probably it makes sense to yeah, it's printing them on separate lines. I think it makes sense for it to be on the same line. Can we do print? Yeah, we can format this, it's fine. But anyway, it also even gives us the kind of error. I think I want to see this better. Maybe. Maybe I want to do a because we're using a print here, can we put a space? Oh wait, no. Can we put a space here? What's the problem? Oh yeah, I didn't have the bang. I forgot to put that. Okay. I need a new line character. No, not there actually. No, not there. I need a new line. Yeah, I think I need it. But wait, there's a new line character already, but why is it doing input and this when this is a print line? But whatever. Anyway, we see that I don't want to waste time on this one. Yeah, we have the error, double error. Oh yeah, it's even saying double error input. I think it's from here actually. He's printed the format. Okay. Let me see. Using print with a format string that ends with a new. Oh no, I already took that out, right? Is that not? Yeah, exactly. I already took that out, so it's not necessary anymore. Anyway, I think we saw that already, so that's okay. Um, yeah, this is sort of what we're doing. All right, so this is done. Let's see other uses of the question mark operator. So in our previous example, our immediate reaction to calling parse is to map the error from the library into the boxed error. So after we call parse, yeah, we map the error using into. The into method on the into trait. Okay. So it's talking about elision, if this can be elided. So we don't have to do this thing. So says we can use the question mark operator. All right. And it says that the question mark operator, it's either unwrap or return error. Okay. So if we use the question mark operator where the error is convertible to the return type, it converts automatically. So we can elide that. And how would that be? So the map error will go away when from is implemented on our error type. Wait. So let's see that before we check what they did. I want to see if we can try to do that ourselves. So it's talking about in our and then function. After we parse this, the thing we try to do immediately is to map the error using from. So what it's talking about is that why don't we try to replace this with the question mark operator. So basically here we would do this and get rid of this. Yeah. And oh yeah. I mean, at least this would give us an iter2 value. So it will give us the value contained in the result. We don't have to map an error anymore, but okay. I don't think we need to map this anymore if we're using the question mark operator in this case. Okay, but yeah. So if we did this, do we know how to? This would be a first of all, if this fails, it would be a parsing error. Do we know how to go from a parsing error to a what's that? What is here? This is an error. It's a box error. Okay. So for our type, which is a double error, from is not implemented. So I think that's what they were talking about. So what do we need to let us go be able to go convert to error from double error. But look, we have okay, error is this is an error first of all. So that won't be enough from what it's saying. Hold on, let's see the from trait, and so it's used to do value conversions. Because we did it. You probably hear some noise. It's drizzling or something. Okay. The conversion is what I'm looking for. Anyway, the from method is where I think I was seeing some examples earlier. I think they had given. Okay, that's the first example. So this is an enum that they have here. It has two variants, IOError, pass error, which this takes an error, IOError, this takes passing error. Yeah, this is our own error type in this case. So now this is how it's done here for their part. They're specifying how to go to an IO error from a CLI error, and the from takes wait. It takes an error that is an IO error, right? And it's able to create a what is this one actually? A CLI error, IO error. Actually, this means this is actually saying how to go. How do you read this actually? From is this going from an IO error to a CLI error here? Because in this case, CLI. Yes. Okay. Wait. CLI error is our own error here because we have it in this enum here. So if we get an IO error, we're specifying how to go to our own target error here. But then this other one here is to go from a parsing error to our error to a CLI error. All right. And so in our case, we would need to implement from for in this how would that look like? Let's see. Where does it come from, by the way? It's in the from trait is std convert. Okay, well it's present by default. So we want to go. We're having a parsing error, and we want to be able to go from a parsing error into our own error, right? Yeah. So that's what we want to do actually. Maybe we just say, wait, first of all, okay. So okay. Um, yeah. Okay. But that's not the signature, right? So will this work? Okay. So here we implement the from trait. I mean, we don't put it specify anything because the unit, the struct is unit right now. So in any case, inside of our and then function, we can specify that the value, maybe I want to just see the type. The value here is, you haven't mismatched types. Yeah, that's fine. We haven't finished writing this. So yeah, parsing this, you have this, and I want to see. So you have an I32. Oh yeah, let's say we wait. Okay, so this would give us an I32 value because we are getting the content of the OK variant of this result. Yeah, and automatically doing automatic conversion because the question mark operator uses the from traits from method to go from a parsing error here, parsing error to our error, which is a double error. So it knows how to do that. We've taught it how to do that. And so now, yeah, exactly. So now we need to, what needs to be returned from here would be a result of the doubled value. Yeah. So we can do something like okay of val, yeah, I don't like all this. It's very noisy. So wait, um, why is it still showing me inputs? Did we do that? No, we didn't. Yeah, okay. So for the first one it was doubled, yeah, 6. Second one, we have double error, and it tells us it's kind of error. I mean, it's a double error, sorry, for the second one. The third one is a parsing error, and the problem is invalid digits, right? So that's like for these three invalid digits. This one is just a double error. But wait, we also specified how to format the error. So why is that not the case? Actually. Okay, so let's see if we can get this again. Yep, okay, much better. So for the first one, result is 6. We succeeded in doubling it. That's this. First element was doubled. Second one, which is the empty vector, the error is invalid value to double. Exactly. I think it was about how we're printing this. Yep. Invalid value to double. And that error is coming from our displays FMT method, which we implemented. And the third one, which is where we have tofu that we try to convert to an integer or to a number type, we get invalid digits. Oh, wait, there's one. Yeah, invalid digit found in string. Right. Okay. So what if we did not have the from trait implemented? What would happen? Let's see. Wait, not there. That's not what you want to do. Oh, come on. Okay, and so if you don't have that implemented, what would we get? Does it know how to do that? Still, let's find out. Still knows how to do that. So we didn't need to implement that. Did we already take care of it? So look, we did not. So it knows how to go from a parsing error. Wait, from a parsing error to. Oh wait, I think that's yeah. Wait. Parsing error is an error, and what we specified here is an error. Is that why? What if this were not an error? What if this were let me see, what did I have here? Wait, sorry. They also have error here, so that's not it. They implement error, they implement display. They also did not implement the from trait, so that's not necessary actually. Oh, they also did this stuff that we did here actually. I mean, they didn't use the add and then, they just got the first parsed and then that's it. But let's see what they said about that. So the question mark operator, it actually means unwrap or return error from this between different types. That means if you use the question mark operator where the error is convertible, so the error is convertible. That's why. And why is it convertible? It's convertible because what we want, the target is an error type, which is error from std error. Target is error, and the input is percent error, and percent error already implements a from implements the from trait, so it knows how to do that. That's why it works. What if we were not returning this? Is it possible for us to say that it's only a double error that we want to return from here? Curious. I think the struct is not yet known, right? At this point, is that what's the issue is? Why? Okay, that's not a problem. I'm trait expert. Yes. So I need to what? I need to use a trait actually. Okay. I need to see what happened. Well, I guess we get a compiler or something anyway, but yeah, it's fine. At least we know. But anyway, we're able to implement the from trait, so that's fine. On to the next one. Oh yeah, they also did some cleanup, by the way. So instead of doing the, yeah, look, we don't need to do the and then anymore. I think they just did something much simpler by saying, let this be vec.first. It's an option, yeah, and we can get the value that is in the sum variant, or if it's none, it would go to a double error. Assuming it knows how to do that automatically. No, wait. No, that's not. It doesn't know how to do that automatically because. I mean, like, how would you do that? No. So I think it's we have to convert this to a result because what we expect is a result, not an option. So we have to say okay, or I guess, yeah, okay, or, and we okay, or would convert an option t, option of a type, to a result of a type, or yeah, on error. So basically you have to provide the what should be in the error when it's none for the option here. So I think we would need to say this is a double error. We need to teach this, I mean, like, specify it. Okay, so we get that. We can say doubled now would be the first, which is a string slice. Turbofish operator. We parse this. Now we have the result of parsing error clear, and we use the question mark operator to terminate it. I mean, short circuit it. If it fails, it knows how to go from a parsing error to an error because it's already implemented, and we just returned doubled. No, actually we returned okay doubled because it needs to be a result. And that's it. We don't need a wait. We don't need a yep. Much smaller and neater actually. All right. What's next? Wrapping errors. Okay, an alternative to boxing errors is to wrap them in our own type. Yeah, I think I like this one from before. So we create our own type of error. Yeah, I think I was attempting to do this earlier too. So basically we have our type of error, and if you notice we have multiple errors that can be returned. One is when it's empty, another case when it's a parse error. Yeah. But this is an enum. Oh yeah, look what we're trying to do earlier. But it said it should have been a trait. What was that? I don't know. But anyway, we can try to return our own type of error. I would actually want to try this out maybe without looking into what they've done first, and then we see what breaks. It says we will defer to the parse error implementation for the error, supply extra info records, adding more data to type. So this is parse, and there's a parse int error. Okay. Yeah. So maybe we try to do that and see how far we go with that. It's a double error, but no longer is it a unit struct. We want to instead use an enum because it's a better thing to say that all the errors are of a particular type. So we can say this is an enum double error, and there's the case where it's an empty vec, there's nothing, and it can yeah, it can be a parse error. I mean, we can actually say it's a parsing error, right? Actually, yeah. Well, let's just. Why don't we just say it's a parsing error? Are we saying? Okay. And so we specify display. No, this is not what it should be, because again we have two types of errors here. So I think we can. So based on the error, we can match, right? Can we match on self? If it's an empty vec, excuse me, an empty vec, then we can say, yeah, with an empty vec, we can say, yeah, we can say that yeah, and if it's a parse of whatever, So essentially an improvement on what we had before for the display trait implementation. So again, double first, we call it double first result. Yeah, it's our own type here. Now we can, again, it's still a double first result. So OKR, it says expected, wait, sorry, I don't know. Yeah, this needs to change. Yeah, we don't need a box type, right? We can just return, this can be a double error in the, sorry, yeah, double error can be in the error, what's contained in error. So expected value found enum double error. Hey, thanks for the follow. So yeah, so for here, what do we do? Do we know how to go? Wait, we still say that error is double. We implementing error for double error. Do we need that? We don't, right? Because we are not returning that. We're not returning error. This is not necessary anymore. And okay, or so if we're not able to get the first element here, this is an option, but this returns an option. If we're not able to convert that to a result, yeah, then the error here would be what? What would it be? I guess that would be the case where exactly where it's an empty vec then. Wouldn't that be the case? Yeah. And here we try to automatically convert a parsing error to a double error. It doesn't know how to do that. So the question mark couldn't convert the error to a double error. Yeah, so we need to sort of teach this how to do that, specify how to go from a parsing error to a double error. Let's do that. I think it's similar to what we did before. So we need to implement from for double error. Yeah, and then we need to so this is to go from a parsing error to a double error. That's what self is here. And how do we go to a double error? It will be double error parse, and there we give it the value. Yeah, value is a parsing error in this case. And Yeah. And our error is gone because we know how now to go. We're passing the error to a double error. Why does it say field 0 is never read? It's double error has a divide implementation for the thread debug, blah, blah, blah. Okay. Yeah, let's run this and see. Yeah. So for the first one, look what we're doing. We have 3 vectors. The first one is numbers. So we have like 3, 4, 7, 7. We're trying to double the first item in this vector. First item here is 3. What we get result as, oh, what do we do there actually? I think there's a bug somewhere. Oh yeah. So look, we didn't multiply this by 2. Okay, I was wondering what went wrong. Okay, yeah. So yeah, so 3, yeah, so we double it, we get 6. Second vector where it's empty, the error is cannot operate on an empty vector, so we are more specific because we are using our enum enumeration where we specify the different types of errors, and we took care of the display based on the error type here. So yeah, this is where the error message is coming from. And then for the last case where we try to take tofu and convert that to a numeric type and then multiply it, we're getting invalid value to double. Okay, is that like what it did? Let's see. So you have a reference to self in display, and they're matching on the on what's this, the referenced, the referenced self. Okay, and then based on whether it's empty vec, okay, they something similar to what we did, and then pass, and they use the what is this operator actually? Well, it's to elite that, it's not necessary. So it's similar to what we did, and they did something extra. They implemented error. Why are you what are you doing with error? So they implemented error for double error, and they implemented source function, and they're matching the source and saying if it's an empty vec, then it's none, because this returns an option. So the cause is the underlying implementation error type. It's implicitly cast to the trait object, and then here they parse reference error to sum. So it's just a matter of being able to go from error okay, so for that, this is just for source anyway. And what they did here is also to implement yeah, we did this one. We specified how to go to a double error from passing error. That's how the question mark operator picks it up. And then what did they do? Yeah, we did this as well. We also did exactly this, but I think it wait, look where they used this. So they match the result, they match on the result, and then based on the error, they want to get this cost by. I think that's what that's the so they said if let, so if e dot source error dot source destructures into some source, then you want to print the cause. Is that why you implemented error? Oh, that's why you implemented source. Does it let you? Right. So you said the cause is the underlying implementation error type. It is implicitly cast to the trait object reference the error. This works because the underlying type already implements the error trait. Right. It works because the underlying implementation already implements the error trait. So that's why you can get cause. I'll be right back in like 2 minutes, just a second. Okay. Am I back? Wait. Okay, I don't know. I am back. If you're able to hear me, maybe you can just tell me. Maybe in the chat or something. Do you hear me? You hear me?
Stay with me while we weep. Don't worry, just believe me. This valley will relieve us. Stay with me while we weep. Stay with me while we weep. Don't worry, just believe me. This valley will relieve us. Stay with me while we weep. Stay with me.
And specifically the source. Yeah, because that's what we did here. Error the source. Okay. Yeah, I wanted to try that, but I think it helps with the understanding of what's going on. So what do you want to do?
Just like the wind, she slipped through my fingers. Just like the earth beneath fell away, and this blinding flash of memories played before my eyes, and all I saw was you. Hey. And all I saw was you. I felt the pain as she walked away from me. Yeah, just like a fire that scorched the land around me. Yeah, and this faded string of hopeless dreams played before our eyes, and all I saw was you.
What do we have for this, by the way? What is so? This is we can have two types of errors, right? In this case, so it's either it's a what do you call it? It's empty. Do we have empty vec here? What is it? Sorry, I think that was. Alright, it's empty vec, exactly.
Close your eyes and just stay tight. We have to go. Stay with me while we leave. Don't worry, just believe me. This journey will relieve us. Stay with me while
it's not. It's okay. I think it changed.
It wouldn't be right to say anyways for the nice man we made with salt and blaze.
Time's and decays, never to return, never to feel whole. Isn't it so easy to lose yourself in time, to draw a finish line, to give yourself to one beyond what's good and bad?
That it will be taken care of, but the kind of error is
It kills
the
me
thing.
not to know.
So you know that if it's a pass error, in this case it will be a parsing error.
Lost beyond the edge, planning what to say. It kills me not to know, but yet I carry on, letting go of safety, holding on to fear. Will you be there when beyond what's
I
gone?
think we wanted to How is this different?
I feel like I fought all my life for this. This one part, this 1/3 I've always missed. No, just don't let it go. I started the fight, but now I'm losing. So will I fall again? I'm scared of heights, yet it was me who ran away.
Oh, I can't forgive, can't forget myself. The piece that I'm missing, it kills me inside. I need help, oh please give me back. This one part, this 1/3, I'm sorry I lost it.
No, I let my weapons fall. I'm drowning in the fears, and now I know that I will fall again and let it go, but I can't stop to run away. To run away.
Run
We summon the error, and then
run
you
away,
can here.
run away.
Why do you say you do not have source on the error? Error is a double error. We implement error for double error. So double error is an error. Yes. So you can actually do source on it.
What a simple thing that started. What a tale for the time departed. Read the book to the final chapter. Start again cause I'm lost hereafter. Never felt this way before. Feeling lost without the cure. No one there to hold your hand. Cause you feel no one understands. You feel your soul falling like rain from above. Down on your knees crawling, and you don't know what for. Just let it rain on your face. Tied up in chains, no one remains. Just let it rain on sweet embrace. Tied up in pain, and no one can save. Now
Import the error thread. Let's print the course.
what a simple thing that started. What a tale for the time departed. Read the book to the final chapter. Start again cause I'm lost hereafter. Never felt this way before. Feeling lost without the cure. No one there to hold your hand. Cause you feel no one understands. You feel your soul falling like rain from above. Down on your knees crawling like you don't know what for.
Tell you what,
Just let it rain
this
on
is
your
the
face. Tied up in chains, no one remains. Just let it rain, no sweet embrace. Tied up in pain, no one can save me now. Just let it rain.
So we have first one succeeded, we get a result. Second one, we have that we cannot operate on an empty vector. Because when it's the case of an empty vector, we just return none for source. In the third case, it's converting a string vector field. We have invalid value to double. Because there's an invalid repeat. Okay, so that's fine. And we can Yeah, we can try to continue. Yeah. So let's see. What's next? Iterating over results. So how can we iterate over results? So, yeah, how can we iterate over results? Showing us here an interior map field. Yeah, so basically going over, like mapping over an iterator. Operations might fail. You want to collect or do something with your errors. That's what happened here. So you have strings. We have a string literal and two numbers. Then make the vector into an iterator or that iterator vector and map over it. Pass system. But the first one is going to be the result will be because again and of course it's either okay or an error. Other two are actual field items with a filter map. So basically you get an iterator over a vector and then a filter map on each item where we successfully pass it to a number or a numeric type and the results are okay. Yeah. Okay. And then for the result, we would only have 93 and 18. The first error will be done. Yep. That's what it's done. And then another thing we can do is to collect the field items with map error and filter map. Error calls a function with the error. So by putting that in the previous one, you can save them by iterating off to the side. So basically, we have an errors variable, which we declare as a new vector, or we create a vector, and that's an errors variable. And then we go on the iterator over this vector. And type So errors.push. I need to see what that gives us. But if we're calling .ok, assume errors.push would either be an option, I guess. How does it do that? This is doing a parse I32. Oh wait, we're collecting this into a vector for known types. The other one, we are collecting it into a result that has vectors. That has a vector, sorry. So it can be turned into a result with a vector of type and error. Once a result error is found, we can terminate. Okay, I think we need to write some of this code. So we get to see how. First iterate over the result. try to parse each item here, and yeah, this would, by the way, give us a result. This is still an iterator because these are intermediate operators that we have here. And we can call collect to do processing. What's wrong? What is this? Evaluate of diversity vec using data equal to evaluations of so what we have and you call
In my mind there's a hole and I don't know why. Oh, it won't go away and I can't take this fight. I don't know what it is that occurs in me, but all I can think of is her. And baby,
projection on other like this. And I say DB is just it's pretty much what I
Oh wait, I can't take this I don't know what it is that occurs in me, but all I can think of is her. Invade me. Invade me. Invade me. Invade me.
Filter map. Convert the result to an option. Convert the result to an option.
Wanted something special, give and take, make or break. We've broken all the thresholds. Look what we have made. If you lie for me, I will lie for you. Give you all of me. It is all for you. Something special.
Right. Wait. Let's see. I tried to map this thing. Right. I think this was the issue earlier. So I had done something like this. Mapping this, we don't want an option. We want this to be the result. So I think this was the key difference here. So you basically you're mapping over the elements of this array. Yeah, iterating over the. You get an iterator on the array. You map over the elements. For each element, you parse this, and because you specify the type of the vector that you want here, it will mostly convert. And here we can do. I tell the vector to be an error and the others are okay. So that's what we see inside of it. So again, this is just iterating over the collection. Yep. So
look what I've become, sitting way up here. All that I had done, everything seemed clear. The pressure's on, I can't go wrong. I worked so hard just to get here. Don't look down, you'll hit the ground. This vertigo's got me minded. Oh, how the mighty fall. Sky's the limit after all. Oh, how the mighty fall. Sky's the limit after all. Oh, how the mighty fall. Sky's the limit after all. Oh, how the mighty fall. Sky's the limit after all. atmosphere. All that I had done, blood, sweat,